Welcome to clickmyproject.com. Project title: A novel congestion avoidance technique for simultaneous real-time medical data transmission. Let's see the abstract. Nowadays, the use of wireless body sensor networks in medical services aims at providing continuous monitoring of patients' psychological data. Congestion may lead to high number of packet loss and unbounded delay, which are critical and may lead to wrong diagnosis. Thus, this paper aims at improving this limitation using a novel congestion avoidance technique to avoid the losing real-time and life-critical medical data. The performance evaluation on RT-MMF technique shows the remarkable performance improvements while maintaining the desired quality of service than the existing system. Let's see the flow diagram of our project. First, the network is formed with the number of sensor nodes, and the server nodes and the doctors are all set up and created the network. Then find the candidates, that is, find the human bodies which have the data that ready to transmit. It is done by using the relaxation theory. Then, if the candidate's data is greater than the bandwidth or not is verified. If it is validated means then MF implementation is processed. If not having the enough data by the candidate, then it again finds the candidate that have the enough data to transmit. After the MMF implementation, the performance analysis is processed in which the existing system is compared with this proposed novel congestion avoidance technique. Let's see the running procedure of our project. To run the code, first open the terminal window. Then go to the directory where we have the code. Then type ns space filename.tcl. 80 nodes is created and the coding is running now. The arrival time of each and every node is updated and printed in the terminal window. Also, the flag that's set to the node which is arrived are also calculated. This is the network animated window. Here only we see the simulation result. To see the simulation, these are the number of nodes. To run the simulation, click the play button. We can speed up the simulation process. So here, according to the medical sensor network, the nodes are created and the network is formed. These are all the sensor nodes that fixed in the human body, and these are the devices that which is gathers data from the sensor nodes and transfers to the server. This is the relay node for collecting data. These are the three servers which is used by the doctors. So here the doctor and physicians is present. They also are considered as a node. The parameters from the sensor node is transferred to the device and then it forwards to the relay node and it goes to the server node. Here the number of patients is set as 3. So from the 3 devices it transfers gathers data. After reaching the relay, it further forwards to the server. While the data are updated to the servers. Then the doctors gets the data from the servers and verifies the patient's condition from their brace. These sensor nodes are fixed as in lungs, heart, to see the patient's body condition. Now the relay node collects data from the sensor nodes. Now the relay node, you can see that it forwards the collected data to the server. The server 2, server 1 and the server 3. All the three servers are get updated the patient's information, and then the doctors see the patient's records from the servers. So this is the medical sensor network which we perform the data transmission. To see the performance, back to the terminal window and type GNU prod file name dot prod. This is the delay graph that exists in the network. Here the nodes is compared with the delay. That is, the number of nodes are varied, that is, human bodies are varied, and the delay is calculated, which is done by between the source sensor nodes to reach the server. Time delay is find out. The existing system have higher delay, but our proposed system using this RF implementation, we get better results. To see the another graph, type GNU node file name dot prod. This is the packet drop graph. Here the number of nodes is varied and the packet drop is plotted. The existing system have higher packet drop, but our proposed system implementation have lower packet drop than the existing system. Thus, the overall performance of the wireless medical sensor network is increased than the existing system.